This section is on a very important topic called linear regression, and it calculates a line that best represents a set of data points. It is used to model trends and predict the future. The calculations for the line minimize the distance between the line and the data points. So in the picture, we have the data points, and the line is representing that data. So if trends continue, we can make estimations about the future. A residual is the difference between a data point and the regression line. Now the least squares method is used to calculate the regression line. So the linear regression line is also called the line of best fit or the least squares regression line. And this is because it is the line that minimizes the sum of the squares of the residuals, making it the line that best fits the data. So we are trying to calculate the line that gets as close as possible to all of the data points. The correlation coefficient R is a measure of the strength and the direction of a linear relationship between two variables. The value of R will be between -1 and +1. The closer R is to -1 or +1, the stronger the correlation, and the better the line fits the data points. The coefficient of determination, R squared, is the amount of variation, which is the vertical difference from the data points to the regression line, that can be explained by the relationship between x and y. The rest of the variation is due to other factors, such as sampling error, coincidence, or lurking variables. So for example, if r equals 0.9, then r squared equals 0.81. And if we interpret r equal to 0.9, this means that the data has a very strong positive linear correlation. If we interpret r squared equal to 0.81, this means 81% of the variation in y can be explained by the relationship between x and y. The other 19% of the variation is unexplained and due to other factors. And on your calculator, make sure diagnostics are turned on in order to show r and r squared. So to turn diagnostics on, we need to press second and then the 0 button to get to the catalog. And then within the catalog, we need to scroll down to diagnostic on, and then press enter, and then enter one more time. And we should only have to do this once. Number 1 says, for the following dataset, find the equation of the regression line and round to the hundreds. So here is our first dataset, and the first step is to enter this into the calculator. I'm going to press the Stat button and then select Edit under the Edit menu. And in list 1, I'm going to type the x values, and in list 2, the y values. And then quit out. Next, we are going to calculate the regression line. So we have to go back into the Stat menu, but this time over to Calc, and then down to Linear Regression. On my calculator, it shows up on the home screen, and I just need to press enter one more time to get to the answer. Now, it's possible that you have the version of the calculator that takes you to a different screen, but all you have to do is go down and press calculate, and then you should arrive at this screen. So y equal to ax plus b is the template. So a is -0.6 and b is 10.2. The correlation coefficient is -0.875 and the coefficient of determination is 0.766. So part A is y is equal to negative 0.6x plus 10.2. And I'm going to skip down to part C and D and record my r and r squared. Now let's graph the data points and the regression line. I'm going to press the y equals button to get to the y equals menu. And we need plot 1 to be shaded. So we need to press up and then enter and then press down to get back to y1. So in y1 we are going to enter the regression equation. Next we need to press zoom and then go down to zoom stat. So what zoom stat does is it makes a window that fits all of the data. And this is what our graph looks like. So here's the graph. Now we still need to interpret the correlation coefficient and the coefficient of determination. So r is equal to negative 0.875, which is very close to negative 1. So this has very strong negative correlation. And the model fits the data very well. And we can see that because the line is very close to the data points. The coefficient of determination is 0.766, which means 76.6% of the variation in y can be explained by the relationship between x and y. The other 23.4% of the variation is unexplained.